Okay, so in this video we're going to talk about how can we address an augmented matrix and give the solution for the system of equations that it represents. Well, there's several different ways that you can do this, okay? So I'm going to show you 3 different ways. And for this kind of problem, you can do it any of those 3 ways. All right, so first I want to make sure that you recognize that this augmented matrix really represents, so that is really thick. Let's go here. That's something like this. Okay, this really represents a system of equations, and if this is, they're telling us it's an x, y, z. This is x, y, z, and constant. That means that this is x minus z is equal to 3, negative 7/4 x plus y minus 5/4 z is equal to 7/4, and 4x minus 4z is equal to 12. Okay, so recognizing that the matrix represents a system of equations is key. All right, that allows us to use either RREF, Kramer's rule, or the last one is using a matrix, an inverse matrix system. Okay, so the easiest thing to do is use RREF to get, to convert this matrix into reduced row echelon form. Okay, and Alex shows you how to do it by hand, but I am very content with you using your technology in order to do this. And so I'm going to show you how to do that. Let's go ahead and switch gears. We're going to go to a graphing calculator, okay? All right, and so we're going to put this calculator, or this matrix, into this graphing calculator. So we're going to select, oh no, I need to go back. I haven't really used this calculator. I just was looking for one that did matrices. So we want to edit a matrix and make it a 3 by 4 matrix. Okay, and no, I didn't want to do that. This needs to be 4 matrix, 3 by 4. Okay, and now let's put everything in the matrix. So 1, 0, negative 1, and then 3. And then what? Negative 7 divided by 4, 1, negative 5 divided by 4, and then positive 7 divided by 4, then 4, 0, negative 4, 12. Okay, all right. So now we have matrix A input, and I always double check and make sure that I put it in correctly. So I will actually quit this and go back to my matrix menu. So let's see, second matrix, and just, I don't want to edit it. Second matrix, names. And I'm just gonna have it, oh, no, that's not what I want to do at all. This is what happens when you're using something you're not used to using. Let's see, oh, I just want to quit. Okay, quit first, all right, and close that. And then I've called matrix A here, so I just want to look at it and make sure that what I put in is correct. And it's looking pretty good, yeah. I've got all the signs and okay, yeah. So I typically will make an error and not include a negative where it needs a negative. So I always look and see what's going on. Okay, so now what we're going to do is we're going to go to that matrix menu. Oops, second matrix. Okay, and we're going to go over to the math screen here, and we're going to go to where it says RREF. Oops, I don't know what happened there. RREF, right? And then we're going to call the matrix that we just put in there. And let's go back to matrix names in here. So we're wanting to find the reduced row echelon form of this matrix A. So we're going to press enter. All right, and now I have the reduced row echelon form, and I think that you may have done some problems where you interpreted this. Okay, so notice that you've got, I'm going to have to do a cut and paste on this. Well, no, I'm just going to actually put it on 0, 1, 3, 7, and then zeros. Okay, let's go back to the whiteboard here. All right, and so we have this matrix now that we are going to sorry, this is a little bit awkward. So here we go. We've got this matrix. We've got 1, 0, -1, 3. Then I've got 0, 1, -3, 7, and then I've got zeros along the last row here. Okay. So remember that if you have zeros all along the last row, this means we have an infinite solution case, all right? So let's look at the equations that come out of the first two rows. I have x minus z is equal to 3, and I've got y minus 3z is equal to 7. Okay, notice that we can easily solve for x and y in terms of z. So we can say that x is equal to 3 plus z. And we can say that y is equal to 7 plus 3z. Okay, and so I can put my x value in, I can put my y value in, and they're all in terms of z. So z is just going to be my final solution. Okay, so if you wanted to write your infinite solutions in terms of x, y, and z, it would look like this: 3 plus z, 7 plus 3z, and then z. All right, now in this case, is asking for specific solutions. Infinitely many solutions, 2 of which are. Okay, then all I really need to do with that is select a z value and then find what the x and the y's would be. So let's just say that let's let z equal 0. Okay, well then this part would be 0. And then I would plug in a 0 here and I'd get a 7 out, and I'd plug in a 0 here and I'd get a 3 out. All right, and then let's say for another one, let's let z equal 1. All right, and if that's the case, then I'm going to plug in that z right here, and I get 7 plus 3 is 10. And I plug in a 1 right here for z, and I get 3 plus 1 is equal to 4. So I could put those up here as specific solutions. Okay. If by chance you get something when you get your RREF form that is the last row doesn't look like zeros all the way across, but zeros and a value, this is going to tell you you have a no solution case. Okay, when you have a value right there, but zeros along that bottom row. Now, if by chance you have the nicest possible thing, which would be something where we have 1s on that main diagonal, 1, 1, 1, and zeros everywhere else in the first three columns. That's going to give us a unique solution, and you would find the x, y, z's just by that last column. Okay. All right. I think that is all we need to do. That's probably the best way to attack these types of problems. It's a little bit more challenging to interpret well, this is the easiest way to interpret these kind of problems. So hope this helps you. Talk to you soon.